Good morning, everybody. Thank you for joining us for this web seminar this morning. The title of the presentation is Time-Sensitive Networking, What, Why, and How. And this is part one of a series of webinars that we will be doing over the next few months. So we hope you find this informative, and we hope you can join us for the following events too. So my name is John Browett. I'm the General Manager of the CC-Link Partner Association in Europe, and I'm joined this morning by my colleague Chih-Hong Lin, who's from Moxa. And Chih-Hong, can you just introduce yourself, please?
Yeah, thank you. Thank you for having me. Hi, good morning, everyone. I assume you are living in Europe. So my name is Lin, Chih-Hong Lin. I originally come from Taiwan, where our Moxa company headquarters is based. Now, in the meantime, I've been living in Germany for 27 years now, so I can speak quite some German. My role at Moxa is a global technology partner manager. So I'm responsible for managing and developing partnership in emerging new technologies such as TSN today, 5G, but also other topics like Single-Pair Ethernet and so on a global basis. So it's my pleasure to join John today. Thank you.
Great, thanks very much, Chih-Hong. So yeah, let's get started. So hopefully you can all see the presentation. Nobody's saying they can't, so that's good. So this is the agenda, and basically what we're going to do today, as the presentation title showed, first of all, we're going to talk about what is time-sensitive networking, and then we're going to talk about why it's important. Then we're going to examine how it's been used, and as part of that, we're going to have a case study which gives you a bit of a idea of how it's been used in a real-world application. And then finally, we'll have a conclusion and some more information for you to follow up on if you wish afterwards. And we'll also have a question and answer session at the end. So hopefully those of you who've used GoToWebinar in the past, you know that there is a chat feature, or sorry, questions feature in the toolbar there on your screen. So if you want to ask questions, if you can just type them in the questions box as we go along, and then we will answer those at the end of the session. And then one other point is that please note we are recording this presentation. That the plan is to put this on YouTube at the end, so that for people who weren't able to join us today, they'll be able to watch it too. Okay, so let's get started. So as we said, the first point is what is time-sensitive networking? So basically, one of the things that's driving all this, and so a little bit of background before we get started on the explanation. I think we're all probably familiar with Industry 4.0 now. As we all know, this has been established for a number of years now. But one of the things that Industry 4.0 is requiring is better process management. And the way to do that is to have better transparency of your processes. As you probably all agree, if you don't understand what your process is doing, it's hard to manage it well. So basically that's kind of the underlying principle behind TSN and what we're going to be talking about today. So transparency is a great thing, and I think we probably all agree that we need it. So the question is, how will TSN actually help deliver that? So really, one of the key things that helps this is having increased network convergence on the shop floor, and also between the OT and the IT level. And OT is operational technology, so that's the actual activities on the shop floor with your controllers, robots, and so on. And basically, what TSN is going to enable, or is enabling now, is the ability to have multiple kinds of network traffic together on one network architecture. So that's what we mean by convergence, that's converging these different kinds of networks together on one network. And so by doing that, what it means is rather than having multiple different networks where maybe it's difficult to understand what each network is doing and combining that traffic together and getting one common picture about what the process is doing, TSN will allow that all to be together on one network and therefore make it easier to understand what's going on, and make it easier to capture the data and understand it and act on it. And then, of course, another thing that is important as far as Industry 4.0 is concerned is having bandwidth to handle all this data. I think probably a lot of you have read over the past few years about how Industry 4.0 is also causing a large increase in the amount of data that processors are producing. We've got lots more devices now producing lots more data, so having more bandwidth to handle all that is also going to be important. So what you're seeing now is there's a definite trend in the industry towards gigabit bandwidth on Ethernet networks. People are starting to realize that 100 megabit isn't sufficient anymore, and there's a clear move now towards gigabit. So that's giving you kind of the background about where all this is coming from. So now let's talk a little bit about what some of the key principles are behind TSN and how it works. And basically what you see is that there's a core group of IEEE 802.1 standards that define what TSN is and how it works. And these are extensions to existing Ethernet. And what they do in a nutshell is that they take standard Ethernet and they make it deterministic. And by doing that, it provides the foundation for network convergence, as we just discussed. So for those of you maybe not familiar with the term determinism, what that essentially means in this context of automation is it's making sure that an event happens when you expect it to. So it's quite a simple concept really, but with Ethernet in the past, that wasn't always possible because, as you'll see in a moment, it wasn't always possible to know exactly when something was going to happen. So the first key concept is time synchronization. So what this is defined by a standard 802.1 AS. And really what this does is it makes sure that all the devices on the network have the same time base. So basically they all know what time it is. So if it's 10 a.m., everybody on the network knows it's 10 a.m. All the devices understand this. So, you can kind of compare it to a railway network, if you like. When in the early days of railways, when they first started, one of the things that made it difficult to run a railway network was agreeing on what time it is. If you don't know what time it is, you can't tell exactly when your train's going to arrive at the next station, how long it's going to take to get from one place to another, and so on. And basically, 802.1 AS does exactly the same kind of function for networks. But instead of it being trains moving from one place to another, it's data packets. So basically, by synchronizing all the devices on the network onto one time base, this means that you have very precise control over latency, which is the delay it takes for a data packet to travel over the network from one place to another, and also jitter, which is the variability in the latency. So how does the latency vary from one moment to the next? So by implementing this standard on the network, what you end up with is a very predictable network traffic flow. You know exactly how long it's going to take for a data packet to get from one place to another, and you also have a good understanding of what variability might take place during that time. So the end result is that you have very predictable network traffic flow, and as a result, you have the foundation of determinism. But time synchronization isn't the whole story. There's also the aspect of scheduling as well. So what that means is that you maybe have different types of traffic on the network, and some maybe have higher priorities than others. So there's another standard that goes along with the 802.1 AS, which is 802.1 QBV. And what this does is it controls access to the network for different kinds of data. So, for example, if you're running a machine and maybe you've got a video camera on it that's doing some kind of inspection task, but then of course you've also got maybe safety devices on the machine protecting workers from injury. You can agree that if somebody hits an e-stop on the machine, that's a much higher priority than an inspection video frame. So that's what QBV does. It's basically making sure that the right traffic has access to the network at the right time. So therefore, traffic can flow as required. And again, this is the second part of the foundation of determinism, making sure that the traffic doesn't interfere with each other. So that's giving you kind of a little bit of the technical background, if you like, at a basic level. So let's go on to the why part of the presentation. So why is TSN important? So we can take the standards we've just talked about and we can say, well, what does this actually mean for the user? If you're there building a system in practice, what benefit does this actually deliver to you? Well, as we said at the beginning, the idea is it delivers network convergence. But what that means in practical terms when you're building a machine or a system is that it allows you to combine all the multiple types of traffic together on one network. So maybe in the past you would have had possibly a network for motion control, maybe another one for safety, and so on. Now you can take all your different kinds of automation traffic, so your I/O, your motion, your safety, and so on, and you can put all those together on one network, which that actually is maybe not so new. That capability has existed for a while now. But what is new with TSN is that you can also now take network traffic that maybe doesn't necessarily relate directly to automation devices. So perhaps you've got maybe barcode readers or printers or something on the network too that maybe aren't technically automation devices as such, and maybe they're just talking normal TCP/IP Ethernet. But with TSN, you can now combine this traffic and you can put all of it together on the same network. So, as the little graphic at the bottom there showing, you've got all these different kinds of traffic flowing together on the same cable. And then this also, in theory at least, gives you the principle that not only can you have one kind of industrial Ethernet running on this network, but in theory, you can combine multiple different kinds of industrial Ethernet together. So, for example, you could maybe combine something like CC-Link IE TSN, which we'll talk about later. And maybe you could technically also add something like Profinet to it as well. So, again, this is going to simplify things for machine design and system design. And then the final point is that you will also be able to converge the IT and OT levels in a better way. And again, that's something we'll talk about in more detail in a moment. So let's take a quick example of how the operational technology convergence can operate. So we've got a diagram here which shows there's a number of different devices on a network. So you've got the blue devices, if you like, which are the automation devices. So you can see there we've got a servo, a robot, an inverter, and so on. And then you've also got some devices which maybe are not automation devices as such, that the red devices. So you've got a laptop and maybe a video camera. And so they're all producing different kinds of network traffic. But by using TSN, we can combine them together onto the same network. And basically all these different kinds of traffic don't interfere with each other. So as you can see there in the chart at the bottom of the picture, you've got the blue traffic, which is your automation devices. So that's kind of like your critical process traffic, running the process and making it do what it's supposed to do. But then at the same time, you've got some variability of different kind of traffic on top of that, the red bars. And basically what this is showing is that even though maybe you've got different levels of non-automation traffic happening as the automation process is operating, by using TSN, we can combine that all together on one network and it all works correctly and nothing gets in the way of anything else, and your system functions as you planned it to. And then taking that one stage further, you've got the situation where you need to combine your factory floor maybe with your IT system. So you've got your OT IT convergence. So what this diagram is showing in the bottom half where it says manufacturing system, this is your actual manufacturing area. So you've got all your different machines and processes manufacturing whatever it is. And you can see there by using something like CC-Link IE TSN, a TSN-based network, you can combine all this stuff together on basically one network architecture. So, all those orange lines there are indicating that we have pretty much everything together on just one network architecture. But then as well as that, we can now make it easier to get that data out of the processors and then maybe bring it to an edge server like you have in the middle there. And then that can kind of filter the data to decide what is the most important information that's coming out of the process, the most important data that can then be shared with IT systems and maybe the cloud or whatever. And so the data can be analyzed, the right conclusions can be drawn, we can produce actionable information to improve the operation of the process, and then we can send that back down again to fine tune things and make sure the process is operating as well as possible. So, the TSN is all going to help make that work. So this is all great, and obviously it sounds like it can do some cool things for us. But in the end, everybody's running a business and everybody needs to make money to stay in business. So what are the business benefits that TSN can finally deliver? So in our opinion, this comes down to these 4 points. So what we have here is we've got simpler network architectures and machine designs is probably the first key point. So, if you can combine everything together on one network, it means that you can save cost and make simpler machines that are easier and faster to get to market. Obviously if you have fewer networks to worry about, then the work involved to set them up and get them going is reduced. And as we said at the beginning, what this also will deliver is a increased transparency of the process. So obviously if you have better transparency of the process, you can run it better and make it work better and therefore be more effective at what you do. And then of course that leads on to more productivity. A better run process is probably a more productive process. So you can make more of what you make in a shorter period of time, so therefore meet customer orders faster and so on. And then finally, as we just saw, we can also make sure that the OT and IT worlds are working together more effectively. So therefore, we have that opportunity to improve the operation of our processes in a better way. So with that being said, I'm now going to hand things over to Chih-Hong, and he's going to give you a bit of an overview about how TSN is being used. So over to you, Chih-Hong.
Thank you, John. Can you hear me okay?
I can hear you. Yeah, thanks.
All right. Please go back the one slide.
Yeah. So this is your first slide, right?
One slide back, please. Thank you.
Oh, sorry, one slide back. Yeah, there you go.
All right. Okay. All right. So again, good morning, everyone. Thank you for attending the webinar today. We have been talking about TSN for a couple of years now. So before you join, you may think that, well, another webinar. Let's listen to what those guys are talking. Today, we want to take a slightly different approach. So of course, after you listen to John's presentation about what is TSN and why is TSN, in the coming slides, we're going to share and present we will put more focus on the real cases from the real projects, and especially what are the implications for you, no matter you are factory owner, machine builders, or system integrators. When you decide to deploy and implement TSN, what are the implications for you? Okay, what should you pay attention to? All right. Give you one example. A lot of customers ask us, Moxa, say, okay, I would like to test TSN. Can I buy a TSN switch from you? In most of the cases, we will say, sorry, no. Then the customer are kind of shocked and surprised. What do you mean? Okay, we have been talking about TSN for a couple of years now. Okay, we said because it won't work as you think, right? I'm going to explain this because we believe that TSN is not just a feature or product. It's a technology, it's a system level topic. It's not a product level topic. Means you need a complete ecosystem to make it work. Okay, ecosystem means that inside so-called TSN domain, all components have to support the same set of features, starting from controller, I/O, drive, whatever, robot, including the switch, of course. Okay, and they have to be tested and so on. Otherwise, it won't work. It won't work. What I mean is that it won't work. You won't get the full benefits and values coming from the TSN as technology. All right. So, so what are the real? I mean, the benefits and values TSN technology can provide to you. Next slide, please. Before I answer those questions, I would like to also share some ideas with you. You may ask, well, TSN, it's feasible already for my applications? And how can I know? All right. So I would like to ask you a couple of questions. Have you ever experienced the cost, the integration cost, and it gets higher and higher and higher for the current, no matter standard or proprietary communication technologies? All right. And did you face, I mean, issues when debugging system or troubleshooting, and it becomes also more and more expensive because right now you have, well, different and isolated network infrastructure? And did you have difficulties to manage the network because there are so many different networks? Okay, there are no one single unified or converged network. And have you faced also interoperability issues between OT and IT and different systems? And do you need higher bandwidth for developing a new applications, new system, and so on? And do you want to enhance your network security? All right. If your answers are yes to 2 or 3 or even more of those questions, then I think you need to seriously consider deploying TSN, because TSN will provide those features and benefits to you. Means reduce the cost, to easier troubleshooting, better management of the network, and also to solve interoperability issues and provide higher bandwidth and higher security and so on. All right. So how do I going to implement the TSN for me? Okay, what are the key features, key requirements, and what should I pay attention to as a TSN user? All right. Next slide, please. John?
Yeah, there's quite a lag here. I hit the button, but let me do it again. Sorry.
No problem.
Okay, let's try clicking it. No, maybe that'll work better. There we go. Okay. Great.
All right. Okay. So we think that there are 3 key requirements when you implement TSN, and you want to implement TSN successfully, right? Okay. Number 1, industry Ethernet protocol have to support TSN, not only as a layer 2 transport, but to have full integration. All right. And the second part is that how can we handle the current issue in terms of interoperability between different vendors? All right. How can we avoid that issues happening again for the TSN? And how is it ready already? Do we have enough TSN solutions and products to try and test and even to use in the real projects and so on? So I'm going to touch all 3 one by one in the next slide. So next slide, please. Okay. Industry Ethernet protocols over TSN. Next slide, please. Okay. So CC link Partner Association, CLPA, is the first to have a new spec based on TSN, and the protocol is called CC-Link IE-TSN, already back to 2018. All right, it's the first to have combined Gigabit with the TSN. It also reflects the trend in the industry. Okay, of course, all other major industrial Ethernet organizations have also similar activities, are working on that part. But having that said, I would like to stress the point that CC-Link IE-TSN right now is the most advanced, most complete ecosystem by far. All right. So back to the point, you need a complete ecosystem to make TSN work. Okay. So that's why it's very important to choose the right inter-Ethernet organization and protocols. So next slide, please. So multi-vendor interoperability, I presented earlier that in the current situation, you can't really mix different vendors inside a system, a control system, for example, is isolated. Okay, next slide, please. How can we make sure that we won't run into the same difficulties as of today when we doing the TSN? Okay, the best way would be to solve that before, to have properly tested, and that's why Moxa and also other partners have been actively participating in all major TSN related test beds, no matter LNI 4.0 in Germany, IIC or ECC from the States, actually also worldwide different test beds, and even the AII from China. So Moxa has been actively taking part in all of those major TSN related test beds. We have done intensive testing with different partners inside the ecosystem to make sure that it will work during the multi-vendor environment. All right. So very important to have really multi-vendor interoperability. So next slide, please. So how about the TSN Production Solution? Is it ready for me? Okay, can I buy something? Right? To answer this question, next slide, please. So back in 2019, when before the COVID-19, we had SPS, physical fair, and at the time, Moxa, together with our partners like Mitsubishi and so on, has showcased one unified network for the next generation automation. All right. So we showcase both the converged network, but also to provide flexible manufacturing. And we have also the YouTube video on our website. And later you can see the link to showcase how we are going to use the small scale, but actually very, very similar to close to the real applications. So next slide, please. So even last year in Taipei, when the situation is quite stable, so we had also a physical fair there, and CLPA in Taiwan has also showcased the TSN for smart factory applications. And again, there's also a video on YouTube which you can look at and to learn how you can use TSN technologies for your smart factories. Okay. Next slide, please. So, and as a communication provider, and Moxa has got the CC-Link IE-TSN certified Ethernet switches since a couple months. So we have both Class A, which means more like best effort, but also Class B means very strict TSN features and deterministic. And the best thing is that to see is to believe. I've seen with my own eyes last year that when we have a workshop with Mitsubishi application engineers, and we really test with connecting Mitsubishi controller, Mitsubishi I/O with our switch, and also HMI and so on. And it's very, very exciting to see it really works. It's not only on paper or on certification, it really works. All right. So with that, I want to hand over back to John to talk about a real use case, real commercial projects, and by using the TSN. Over to you, John.
Great, thanks, Chih-Hong. So yeah, let's let's finish up by looking at an actual case study where TSN is being used for real. So this is with an organization in Beijing in China called the ITEI, which is the Instrumentation, Technology and Economy Institute. And basically they're like an R&D body which is involved with China's version of Industry 4.0, the Made in China 2025 program. And ITEI is involved with a strategic partnership with one of our board members at the CLPA, Mitsubishi Electric. And basically what this application is, it's a demonstration application of mass customization. So so what that is when you visit this facility, and they get quite a lot of visitors every year, they've actually set up this this example manufacturing line. And what it does is it actually produces souvenir picture frames, which some of you may be thinking, well, that's maybe not a proper application. But the key point here is that this is intended as a way to promote TSN to other companies and show them how they can adopt it in their own processes. And as you can see here in this picture, this is not like some tabletop demo or something that's been made for a trade show. This is a proper manufacturing, several manufacturing cells. And as you can see there, you know, there's obviously been a lot of money invested into this application to show what they want to show and to show how TSN can benefit manufacturing in general. So so basically there's an MES system over here on the left side. So that's where the orders are entered, and it shows what's happening with the system, and it's got an energy management function and so on. And so that's kind of like your IT level, if you like. And then there's a manufacturing cell in the middle here, which is the kind of processing stage where they take the raw materials to actually produce the picture frames and mill them into the right kind of shapes and so on using the CNC machine tool over here. And then there's also a couple of robots on this side that are tending the machine tool and handling the materials. So again, you know, it's a pretty serious implementation. And then the next step is you have the assembly cell over here on the right side, and again that uses more robots to actually take the pieces that have been machined in the processing stage and assemble them into a finished picture frame and then actually package that. And then the final stage is what they call logistics. So you can see over here on the far right side, there's a big yellow framework there. And what that is actually an automated warehouse. So what's happening there is there's raw materials being stored inside that facility. And so they are being brought from the warehouse into the process. In fact, you can just see down at the bottom there, there's a yellow piece there. That's an AGV, that an automatically guided vehicle that moves back and forth between the logistics and the processing side. And so basically it's bringing raw materials out and it's taking finished products into the warehouse. So you can see that, you know, as I said, this is a serious implementation of TSN, although it is a demonstration. So let's take a look about how TSN has benefited this application. So this diagram here, it represents what things looked like in the beginning when this was first set up. And this was before the TSN network technology was available. So I think probably the main impression you get from looking at this diagram is it was quite complicated. There was multiple different networks there, and you know, there was different networks doing different things, and as a result, it made the transparency quite a challenge. It was kind of difficult to see what was going on in the process to any significant degree. So so this was kind of where it started, and this was where things needed to improve from. So basically what happened was that they moved into an intermediate state, you might say, which is kind of where it is at the moment. And so the first thing they've done is they've installed CC-Link IE TSM, so they actually have a TSN network in the facility now. And so probably the first thing you'll notice is that the number of networks that we had on the previous slide has now dropped. There's only actually 2 networks there now. And so this has already delivered a number of benefits because of the simplified network structure. So you can see those listed down on the bottom left there. So as we were saying earlier, this is kind of delivering some of the business benefits we talked about earlier. So we've got a simpler network architecture. We've introduced gigabit bandwidth. So therefore we've got better process transparency, better analysis of the process data. The productivity can be improved because now it's gigabit. And also, we talked earlier about how there's the MES system there. Well, now we've got a better connection of the MES system to the manufacturing side to understand what's going on in the cells better. So the next step is to move to the final state, and so this is kind of where the plan is to end up. And you may think that this network structure maybe doesn't look that simple, but the key point to notice here is that we really only have one network hierarchy. So all those orange lines is the common network hierarchy using CC-Link IE TSM. So basically what you see here is that all the different processors in the application are connected together on a common network. And as you can see there's multiple Ethernet switches involved to connect it together. And this is what Chih-Hong was referring to earlier. How they're using the Moxa Ethernet switches now to provide the necessary TSN connectivity between all the different parts of the system. So the benefits we mentioned on the previous slide still apply, but now of course we can take this to the next level. Like for example, when it comes to productivity, they're anticipating getting a 10% improvement rather in cycle time. And also, the ability to extract data from the system in a better way, act on it, and produce actionable information that can be fed back into the system in a better way too. So this is kind of like the final step and demonstrates, some of the key benefits that TSN can deliver. So one final point is also to remember that this is an open architecture. So, this is not a proprietary system that you can only get parts for it from one vendor. This is an open technology that anybody can produce products for. So in the case of this particular system, there's a number of different vendors that are involved with it. So, for example, there's Cognex machine vision systems in there, which because it's TSN, they don't actually have to be using a particular protocol to communicate on the system. They can just be TCP/IP Ethernet. There's also condition monitoring systems on here, particularly on the CNC system, to measure things like tool wear and reliability and maintenance and so on. So there's a Scheffler smart check system on there as well, which is also using Ethernet communications on the TSN network to keep track of maintenance data and so on. And then, as we said at the beginning of this section, Mitsubishi Electric is also a key partner in this project. So they're providing a lot of the automation components, so the PLCs, the HMIs, the drives, servos, and so on. But you can see here, that this is combining multiple vendors together on one system. So it explains how this is also an open system too. So we're getting close to the end now. So basically, let's finish up with a few conclusions and some more information about what you can do to learn more about TSN and what you can do with it. So I think the key points to take away from this presentation this morning is that TSN is a key technology for the future of industrial automation. You've probably been reading a lot about it in industry magazines and on different websites and so on recently. But I think the key point to take away now is that this is not something that's off in the future at some point. This is something that's here and now, and we've seen already that with the ITEI application, there's some key vendors in the industry such as Mitsubishi Electric who now offer a pretty comprehensive TSN solution. So they can offer various different automation components to build a system with that all support TSN. So that includes things like I/O, inverters, servos, PLCs, HMIs, and so on. So this is not something that is kind of a concept for the future. It's here and now. You can buy products and you can build systems. And as we said before, there's 4 key benefits that helps to deliver. So we talked already about how the network architecture can be simplified, because now you can go from multiple networks maybe just down to one. So therefore, that's going to make your machine design simpler. It's going to reduce costs. It's going to improve reliability, reduce the need for maintenance, improve time to market, and so on. We're also going to be able to deliver greater process transparency. So as we saw earlier, the idea is that if you can understand what your process is doing better, then you can manage it in a better way. So that leads on to the next benefit of more productivity. A better run process is generally a more productive process, so therefore you can get more stuff done. And then finally, we've seen also about how the integration between the OT and the IT systems is going to improve, because now it's going to make it easier to get this data out of the system. It's going to make it easier to process it and get the right kind of insights to then feed back into the system and make sure we're running it in the best way. So we also now can just take a very quick look about who is the CLPA, what is the CLPA. So the CC-Link Partner Association, we've been around for 20 years now. In fact, we were founded back in the year 2000. And what we do is we're responsible for the technical development and the promotion of the family of CC-Link open automation networks. So as well as CC-Link IE TSN, we also have other versions of industrial Ethernet and in fact field bus too from our beginnings. So I'd encourage you to take a look at that later on. But I think that the key point from this slide is that as you can see on those 3 charts there, the CLPA technologies have been very widely accepted worldwide. We've been averaging double-digit growth over the past few years. So that's in terms of the number of members in the organization, the number of products that are available, compatible products from different manufacturers, and also the number of devices that are actually installed and being used in the field. So right now we have around 32 million devices being used worldwide. So I think that combined with the fact there's about 350 manufacturers now who actually offer different compatible products, I think that shows that that the CC-Link network family has been very widely accepted in many industries worldwide. So if you'd like to learn more about us, about Moxa and about TSN, there's a number of resources you can go to learn more. Of course, there's our own website for the CLPA. You can go and visit that, and we actually have a white paper that you might be interested in that gives you some more information about TSN, and we've entitled that white paper in English The Case for Action Now. And we called it that because, as we were saying earlier, TSN is here and now. It's not something you have to wait for. And the white paper basically lays out in more detail what we've talked about this morning and why we think this is something that companies should be acting on now. And I know we've got some people on the session this morning who maybe are not native English speakers. So we do actually have that white paper available in several different languages. So hopefully you can find a version of it that's in your language, which obviously will make things easier. We also have a YouTube channel. So again, we'd encourage you to take a look at that. when you have a chance. If you just search for CC Link Partner Association on YouTube, you'll find that. And we've got a number of different videos there about TSN, which again, hopefully maybe give you some other insights as to what TSN is all about. And then finally, we also have a virtual booth, which we actually set up about back in 2019, but that actually turned out to be a good move because, as we all know, virtual events have become very much a feature of everyday life now. And given the fact that we can't go to real fairs at the moment in general, having a virtual booth is quite useful. So again, you can use that to learn more about TSN, but also you can see who are the different partners who are involved in the CLPA and what different products they can offer. And then, of course, last but not least, Moxa is an important partner of the CLPA. And as Chih-Hong was saying earlier, Moxa's also offering a large amount of support for TSN systems and building TSN networks. You know, they're really one of the key partners here because they're actually providing the infrastructure components to actually help you build a TSN network. You know, obviously, if you're building industrial Ethernet systems, you're going to need good switchers and so on to connect it all together, and that's where companies like Moxa can help with that kind of thing. So again, you know, we'd encourage you to go to their website and check out their content about TSN as well. So that kind of wraps up the main part of the presentation. So I see we've got some questions already. So I guess we'll attempt to answer those now. So basically, one of our audience members is asking, do we need all the devices in the TSN network to have a common synchronized time? If so, is there a recommended way to make sure all the devices have the same synchronized time? What is the time accuracy level requirement between the devices? Well, I guess I'll start out with that one, and then Chih-Hong, if you want to make some comments too, that'd be great. So yeah, basically for TSN to work, everything has to be synchronized together. Otherwise, as you can probably understand, if things aren't synchronized properly, then it basically doesn't work properly. But you know, this is something that this is what the TSN specifications are intended to handle for you. So you know, for example, in the case of something like CC Link IE TSN, this is all built into the network protocol. So it's not so much that you have to figure out how to synchronize things yourself. That's pretty much handled by the network. As far as what's the time accuracy level required, that's kind of up to you in a way. That's something that's usually configurable, and it kind of depends on what you're actually doing. You know, obviously some processes may be more demanding on synchronization and time accuracy and so on than others. So you know, like for example, if you're doing a high-speed motion application, like maybe you're running a printing press or you are running a high-speed packaging process or something like that, obviously in that case, synchronization is very key, and synchronization has to be very tight. So you know, in that case, you're typically looking at microseconds synchronization between different axes and so on the process to make sure that everything's running together properly. But then, you know, if you've got a situation which is maybe a bit less critical, so, you know, maybe it's an automotive assembly line where, you know, maybe you've got robots that are welding things together and or spraying paint on body shells. Obviously, that still needs to have a certain degree of synchronization, but the motion of a robot in comparison to maybe the axes on a printing press is that, you know, maybe the level of synchronization there is a bit, you know, there's a larger time variability there, a slower process cycle time perhaps, so therefore the synchronization is maybe not as critical. Do you have any comments on that one, Chih-Hong?
Yes, as you mentioned, it really depends on the application, and in fact, the accuracy of the clock itself is down to a nanosecond. It's pretty much similar to the IEEE 1588 PDP version 2 and so on, but for automation part, because we talk about the cycle time in the range of several. For the fastest one, the shortest one is still in the range of microseconds, and for very high speed processing and so on. So this really depends on the application. Okay, and we can't just give an answer. Okay, you need to set up the cycle time for what period? It depends on the overall ecosystem, the overall production line, for example.
Right. Yeah. Yeah. Okay, we have another question. Yeah, please feel free to submit your questions. We still have about another 10 minutes for those of you who can stay that long. Just use the questions feature there on the toolbar. So somebody's asking how to move from 1 gigabit to 10 gigabit network speed. Any thought for the future? Well, that's an interesting question, because I think what we're seeing in automation currently is, I mean, here at the CLPA, we've been a little bit ahead of the curve. We introduced CC-Link IE, which was the predecessor to CC-Link IE TSN, which is still available and very widely used. CC-Link IE was actually the first in Open Industrial Ethernet to offer gigabit bandwidth. So that's been around for a number of years now, and has become widely established. But what we've seen over the past few years is that there's still people in the industry are still kind of catching up to the gigabit bandwidth situation. If you look at some of the competing network technologies on the market, a lot of people are still thinking that perhaps 100 megabit is going to be enough for a while. But I think what we're seeing in the market is that's no longer the case. There's a lot of companies now who are offering gigabit Ethernet solutions for automation, and particularly kind of at the infrastructure level. If you look at the various different switch manufacturers like Moxa and so on, they've been offering gigabit bandwidth products for a while now, and I think there's an acceptance in the industry that gigabit is the way forward. So as a result, you're going to see more and more people moving in that direction as time goes on. As far as 10 gigabit goes, yeah, that's an interesting one. I'm sure in the end, in a few years from now, we will probably start to see that maybe gigabit will also need to be upgraded, and perhaps 10 gigabit will become something that people focus on in the future. But I think at this point, certainly for like the field device level and the controller device level and so on, communications within machines and on factory floors, I think gigabit is going to be able to handle things for a while yet. Maybe we might see for like perhaps high-speed backbones between, say, manufacturing cells and IT systems or something. Maybe that's where you might start to see higher network speeds arrive. And I know I have actually seen network infrastructure devices starting to appear now in the automation space, which do offer higher speeds. But I think that's something that people are going to take a while to get used to. I mean, I suppose the other way to look at this is, when broadband first appeared as a home internet access technology, when people started to be able to put broadband connectivity in their houses, we saw a sudden increase in the number of services that are available. For example, if you go back 10 years or so, 10, 15 years, before decent broadband speeds were available for home internet access, in those days, things like Netflix and so on were not really feasible, because you just didn't have the bandwidth to handle services like that. Whereas today, of course, people are doing all kinds of things on the internet from their houses, streaming video, talking to each other, and many other different services. And I think really the point here is that as the bandwidth increases, the services will start to appear that can use it. So I think maybe the final point on this question is that yes, probably bandwidth will continue to increase in the future, and probably the technology will then also be able to deliver things that we haven't even thought of yet. Obviously there's things that are happening in manufacturing today that maybe 15, 20 years ago people hadn't even thought about. And I think we will see that trend continue. Obviously a key topic for manufacturing at the moment, which has only recently appeared, is artificial intelligence. And now people are talking about machine learning and all that kind of stuff to improve the way our processes can work. And maybe things like that will also be able to take advantage of more bandwidth as time goes on. So sorry, that was quite a long answer. So Chih-Hong, do you have any comments on that one too?
Yeah. Well, I fully agree with you, John. So in terms of the bandwidth, I think you are right that it really depends on where you want to deploy the, let's say, gigabit or 10 gig and so on. We believe that for the in-machine or between machines, you probably won't never need such kind of high speed to 10 gig. But if you are going to build a single infrastructure to connect even IT system or even to connection to the cloud and so on, then you may consider using the 10 gig for the backbone part, okay? However, bandwidth is just one aspect. The other aspect would be to consider the delay and jitter. Even you would have the 10 gig, you still need to face the challenge in terms of the delay and jitter. So you still need to have a kind of bounded low latency or deterministic, no matter 10 gig or 1 gig and whatever. So there are different aspects when you consider building a communication infrastructure. But bandwidth is one aspect, but more importantly for control, for critical data, I think the deterministic will be more important, more critical than the bandwidth alone.
Okay, so I think we've got time for one final question. So one of our audience members is asking a question for Chih-Hong here. So they're asking, do Moxa's TSN G5008 series switches support the IEEE 802.1 AS and the IEEE 802.1 QBV standards?
Yes.
Okay, so yeah, long question, short answer.
But please know that this yes, in terms of the feature and standard, but make sure that you perform interoperability test, because what we learned from the past that each company claims to be compliant to standards. However, there are always a kind of different interpretation or different parameter or vendor specific things you can't really guarantee fully interoperable. So make sure talk to your automation suppliers, get them together on one single table and perform a small scale of the POC, proof of concept, to see that if it really work like everybody is claiming to. All right. From the future point of view, yes, we support, but you need to test for yourself, for your environment, for your test setup. Yeah.
Okay, great. Well, we've had almost exactly an hour, so I think that wraps it up for today. So thank you everybody for attending today. We hope you found this useful. We're planning to put this on YouTube later. So if you've got colleagues or other people you think should see this kind of thing, you'll be able to share that with them. And as we said, this is part one of a webinar series that the CLPA is planning. We mentioned that at the start. So we will be planning to have further webinars on the topic of TSN, and that they will be we're planning to do one next month and then one the month after, and maybe even continue after that. So so watch out for those. We'll be promoting them to all the people who are on our mailing list and on our social media feeds and so on. So we hope you can all join us next time. So I'd just like to finish by saying thank you to Chih-Hong for joining us this morning. And
thank you for having me.
You're welcome. It's always good to have our partners participating in these events. And with that, thank you again, and hope to see you next time. All right, thanks very much.
Thank you. Bye-bye.
Bye.